So while studying for Tensorflow Developer Certificate, I started with the lectures and free book, which is Zero to Mastery Tensorflow. So I was following this course and doing the TensorFlow code, but unfortunately, I got stuck into this thing, which is TensorFlow versus Pytorch. So even though certificate is TensorFlow, I've realized that in 2024, this big debate of TensorFlow versus PyTorch, it's actually more valid and answer you're not gonna like it. If you are new to deep learning, if you're learning it from the first time, then it turns out don't learn PyTorch. Sorry. If you're new to deep learning, learn PyTorch first. Don't learn TensorFlow because there is a lot of things. It was the features were inconsistent. I tried so many things to get it working in the code, and there were lots of to and fro things. The code is just unnecessarily elaborate and it changes quite a bit. If you want to see proof, just go to GitHub and then appropriate libraries. So if I go to GitHub TensorFlow versus if I go to GitHub PyTorch, just check in the releases section of TensorFlow and check in the release section of PyTorch. You will find the breaking changes part, the things which are removed, the things which are added, the things which are behaving differently, the things which are missing. There are so many changes here in TensorFlow because they try to add features, and just like a kid who is trying to help, but in the end they make the situation a lot worse in the similar way by giving more features. Trying to make them work was a headache. Whereas in PyTorch, if you check from PyTorch 1.0, whatever functions they have given, they have a tiny bit less features than PyTorch, but they do not change and everything is coherent. So I found the coherency of the naming to be a lot easier. So PyTorch has that advantage, whereas in TensorFlow, just because so many things change, because you have to check the documentation and kind of like find and maybe remember what might be the right one here, it's very messy. So going back here, if you're new, don't learn TensorFlow first, go for PyTorch. Okay. But TensorFlow is needed for model speed up. If we are training a model and you want fast iteration, in that scenario, we will definitely need TensorFlow, but it's an advanced need. So, what's the answer? If you also want to do TensorFlow Developer Certificate, but I'm saying that don't do TensorFlow, then how to move forward, right? So, thing is, I think we have an answer. Answer is Keras. So another kind of like if you want to check why these things are actually true. So current version of TensorFlow is 2, current version of Keras is 3. This version conflicts with this version. Okay. In future, there is going to come another upgrade which is going to combine nicely with Keras 3.0. So even right now at this moment, making these things work together properly was still a headache. I spent so much time installing packages and getting them to work with each other. It's extremely annoying. Okay. But it's not gonna be that inconsistent in future. So when you use Keras, what Keras is aiming to do is you can run the same code in PyTorch, in TensorFlow, in Jax. Jax is even faster than TensorFlow in many cases. So, by using Keras, which used to be integrated into TensorFlow, you kind of like now, even though are giving TensorFlow certification, the code which you are writing, it's a Keras code, which is a lot easier and it kind of like works with PyTorch. So my recommendation, follow these things, but just focus on the neural network code. So here in this book, they are using the 6 7 stage process of getting the data, processing it, then model architecture, then training the model, evaluating the model, and a lot of the code. If you check some code, which is the essential code, That code is pretty small, the meat of the main thing of the code. But it's the miscellaneous ones. They are annoying. They are time consuming, and it's just you have to write the same code again and again and again and again unnecessarily. This is called as a glue code, in which it is you're writing a lot to do extremely small thing, but you can't avoid it. So for that purpose, if when you're doing this TensorFlow, don't worry about these functions much, is my genuine recommendation. If you can't get them working, do not waste time here. Move forward, get the end-to-end experiment working. Get from data to model architecture to model training to then model experiment. Get this code into this format once and then keep executing that part again and again. So you go beyond this chindi code, I would say. This glue code, boilerplate code, it keeps happening and it's not actually that useful. So get the end-to-end experiment running first. And when you get to that stage where you have gotten that code working once for all, then aim so that it all happens in just one line of code. Because you see here still a lot of messy lines, you don't understand it immediately. So if you want to get it working, Pytorch has this really nice way wherein in just one line, run experiment space options, it takes model and data set and everything. So in just that one line as a script call, you execute everything in one shot. So get to that thing as soon as you can. Do not worry about things of TensorFlow if they're not working. Don't worry, even if you have to check documentation, copy code, get the things working, but understand the concepts of the model, the architecture, the filter, and all of these things. So that's what I did. Okay, so in this course of TensorFlow Developer Certification, the data set they're working on, this Dan starts with is trying to classify between just two classes. Images are normal, big, we might capture from our phone. Our phone is more than 10 megapixel. This is less than 1 megapixel in most cases. So in that small of image, we are trying to understand difference between a steak and a pizza. And as we know, deep learning can work on any data. So it means if we can write a neural network which can distinguish between these two, we can write a neural network to do anything, to do any image distinguishing we want. It could be identifying a specific metal from if we are working on a mining rig or something, to anything, right? So get the data, and here if you check, this is the data download from this, and then these are the things of visualization, and then you specify the links. Then we have this function. I was talking about things being deprecated. This is no longer working in latest TensorFlow version. And even in the TensorFlow version, Keras, which used to be part of TensorFlow, is no longer working. It is now separate. And that library is not going to get updated yet. Like you see the mess, right? So don't worry about these things. Get to the code part, and somehow, if you can, just put it into a format so that in future you can immediately get to the model experimentation. So to do that, I used this and I uploaded that data onto Hugging Face. So you see, what I want to do is on my Hugging Face account, I want to upload all the data sets I am working on so that as and when needed, I can simply just call them in one line. So you see here in these courses, a lot of time and code and things is spent here. What if I want to standardize this? I'm going to process it. I'm going to upload it on my Hugging Face thing. And I'm going to write a code so that in a uniform way, I can get it into the format I want without, writing these many lines, which are kind of like here. So I did this. I still haven't gotten to a better way of writing this code because TensorFlow was bothering me a lot. So I have finalized on the way I want to do it. So here in the Hugging Face dataset, you simply use Hugging Face dataset, download the dataset. I have uploaded it for you, so you can just get it as and when you want. You convert it into TensorFlow format because we are doing TensorFlow certification. When it is PyTorch, you just convert this to, instead of TensorFlow, you use a PyTorch function, right? And in PyTorch, data set, if it is huge, we kind of like don't want to be bottlenecked by memory, so there is a data loader function. So TensorFlow doesn't have it. It's a message to get it working. It's like, you see my annoyance here, right? This is this. I'm gonna spend some time get it working. Then model architecture. So in this course, the model architecture was used as neural networks concept called as sequential model. But here, if you want to actually check what is the output of this layer, what if I want to see, they do some changes on it? What if I run into an error and I can't find out where the problem is? So this doesn't make that easier. So, out of different ways of creating a Keras model, which we use in TensorFlow library, sequential people use, but it doesn't allow debugging that well. PyTorch actually explicitly discourages us from using sequential. It asks us to use object-oriented approach. So in Keras, they have three: sequential, functional. For some reason, they all use these two. But I don't agree with it. I think overriding this thing wherein it's easier to debug is a better way. So the approach is like this. The neural network architecture, which you see here, the same thing as which is written here. I think this is the model which I have copied. Mm, where is the model? Not this. Okay, I don't know where that model code is. As you can see, it's very messy. I've used this. Initialize the layers separately in one place, and this is the forward pass. There are few things I have changed here. For the last layer, everywhere they use activation function immediately inside, but actually the output of the final layer is generally given without activation function, and it is, in mathematic terms, it is called as logits. So if you check here, logits is equal to pre-activation function result. This is what mathematically it is called, and everywhere in PyTorch and for consistency purposes, this is what they use. So we should uh, change our model to be standardized this way. So use this way, override Keras model, and then do the structures, use some of the internal Keras functionalities. Again, this is an important one. Model.layers gives you list of all the layers. So you see, here, if I want to work on checking the intermediary output of a specific layer, this Keras allows me to get all the layers by just saying dot layers. And what I'm doing is, instead of calling, taking the input batch and, directly getting the output of whatever it would have been for all the layers, here I'm going one by one. So I'm going, through each layer one by one, take the output of the previous layer, transform it with help of current layer. That is the intermediate output. Now pass on that intermediate output to the next layer. So that's why we, make the previous input equal to intermediate output. So this is how we are, output of the previous layer goes as the input to the next layer. And it keeps on happening. We go through each layer one by one. So here, if you want to check the internal output, we can simply put a breakpoint here, debug, and as and when needed, we can just live check and get a lot more intuitive feeling of this thing. So I prefer this, like I said, that this way allows a better way of debugging. So then we have model, and then it is model training part. And here, because I changed the format, this a ready-made function of training was not working as is. So this part I have gotten stuck at. I will make changes here, and then we will have a end-to-end computer vision in TensorFlow. So you see, it took me a bit of time, and it is still just 50% complete simply because of TensorFlow inconsistencies. But all of this time is just one-time effort required so that you get the whole code snippets ready and you can train any neural network. So maybe in 2 days or something, I will have this entire thing which is easy to understand here on my GitHub repository. And when that is done, this computer vision module will be done. So I'll apply this to the exercises from, I think, transfer learning. That's where the real work starts happening. So this was the module 3, 50%, first half of that module.